Good morning, students. Let's start our class now. Today, we will be discussing two very important, points, and then we will conclude, our discussion on sequences and series. After that, I'll discuss with you if you have any difficulty in solving any of the DPPs. So far, you have solved, I think, 14 DPPs. So after that, I will tell you that exactly how you can go from the basic to intermediate to advanced type of questions, you know, mm, in this particular unit called sequences and series, leveraging, the online test platform at, uh, KonarClasses.com. Today's, class is very important uh, for two specific purpose because the thing what I'm going to teach you now, that one concept is very rare to find in any books or other materials, and that is also very important this kind of discussion to have. So this particular topic is called finding a sequence using the method of undetermined coefficients. Okay, what is mean by that? So suppose a series is given to you, a sequence is given to you. Okay, so let me first give you the fundamental ideas, and then we will start, working on a practical problem as well. Suppose, let me start with an example. I hope all of you are able to hear me very clearly and able to view the, digital board.
Yes.
Very good. Suppose, uh, a question is given to you. Find the nth term. Find the nth term of the series. What is the series is given? 3, first term, second term 7, third term is 13, fourth term is 21, fifth term is 31, and so on. See, if it is particularly in AP, you can find it out. If it is in GP, you can find out. If it is in AGP, that is arithmetic or geometric progression, then also you can find it out. If it is in HP, that is harmonic progression, then also you can find it out. But if this series, if you look into it, it is neither fall into any of this. Then so difficult, na? Then we can use some trial and error method and find, okay, how it is going to be. But here what I'm going to discuss in the next 10 minutes, dear students, we are going to find a very specific method so that you no need to spend time in trial and error. Is it clear? For example, if you get this question, then how you are going to approach it? If I give you 1 minute to all of you, how you are going to approach it? Your individual thought. Anyone can answer. Okay. So let me explain you how we are going to proceed it. So, and you don't need to apply any trial and error method. All you need to find is that a specific, step-by-step methodology. What we are going to do whenever you see, dear students, whenever you find a series is given to you where you are not able to find any specific pattern in the terms. Specific pattern in the terms means neither in AP, nor in GP, nor in AGP, nor in HP. Then what to do? Then what you'll do, dear students, we'll make a difference of the subsequent terms, the consecutive terms. If we make a difference of 3 and 7, what we are going to get? 4. Then we are going to make a difference between 7 and 13. What we are going to get? 6. Correct, no? Then we are going to make a difference between 13 and 21. What we are going to get? 8. Correct or not?
Yeah.
Then we are going to make a difference between 21 and 31. We get 10.
Yes.
And we will see whether any specific pattern is finding out or not. 4, 6, 8, 10. Are you getting anything?
Yes.
What you are getting?
Common difference is 2.
Common difference is 2 in AP. Okay. But the point is that you are not going to find the summation nth term of this series, no? Which is written in blue. You need to find the nth term of the previous one, which is in red. Correct or not?
Yeah.
Then next step is that, so this, what you call it, no? So it is the difference between 3 and 7, which is coming as 4. Difference between 7 and 13, which is coming as 6. Difference between 13 and 21, coming as 8. Difference between 21 and 31, coming as 10. Correct? And this difference is known as the first order difference. Are you get the point, dear students? This is called the first order difference. So this is what is known as the first order difference. Are you getting my point, dear students? This is a name, actually. It's nothing, nothing special about it. First order difference. Then what you are going to do, dear students, is that I am going to make a second order difference. What is the second order difference? I hope you understand by now. Whatever the series you get, the second one, we will take a consecutive difference between this one. That means 6 minus 4. If you make 6 minus 4, what you are going to get? 2.
2.
Then you difference between 8 minus 6, what you are going to get? 2. Then you are going to make a difference between 10 minus 8, what you are going to get? 2. Correct?
Yes.
And that is called we define as second order difference. Second order difference. If you find that second order difference is constant, that what we are getting? 2, 2, 2, 2, 2. Correct, no?
Yeah.
What we are going to assume, dear students? We are going to assume that U stands for that, undefined. Okay. In this case, I defined UN. What we are going to define UN, the nth term. That's what we need to find, the nth term, UN. Okay. UN, that is equal to nth term of the given series, that is equal to nth term of given series. How you will write, that is equal to A into n square plus B into n plus C, where A, B, and C belongs to the set of real numbers. So what we get? So UN is equal to AN square plus BN plus C. What is ABC? ABC are a real constant. So now what is our task? Our task is to find the value of A, B, and C. Now how many unknowns are there, dear students? There are 3 unknowns, A, B, and C. And as I said earlier, I'm saying now, and I will say in future as well. Generally, when you find that you need to find some unknowns, you need to have that many equations. In general term, I can say, to find the value of these unknowns, indeterministically, uniquely. Correct? Very Very generic term. There are some special cases where this statement is not getting violated, but I'm telling in a very generic way. So how to get this one? What is the value of U1, dear student? U1 is 3, correct or not? That is the first term.
Yeah.
So then if we apply n equal to 1, if we apply n equal to 1, what we are going to get? That a into 1 square plus b into 1 plus c, that is equal to u1. U1 is what? U1 is, this implies what? What we are going to get? We are going to get U1 is 3. So that means a plus b plus c is equal to 3. Correct, no, dear students?
Yes.
Then let's apply n equal to 2. If we apply n equal to 2, then what we are going to get? A into 2 square plus b into 2 plus c is equal to u2. What is the value of u2, Sagnik? What is the value of u2?
4a plus 2b plus 2.
Huh? No, that is the expression. But from the series, what is the value of u2? For that, I didn't ask this question. From the series, u2 is 7, correct, no?
Yes.
Are you getting the point, or is there any difficulty in understanding? Huh?
Yes, I understand.
So then you should say, no, and be a little louder. In my class, you need to be engaged. I want to engage because these are, relatively, not complex, but relatively, very special topics. For n equal to 3, what we are going to get? A into 3 square plus b into 3 plus c, that is equal to u3. Divansu, what is the value of u3?
13.
13, correct. Plus 3b plus c is equal to 13. And I'll stop here. So what will be my task? To solve these three equations. What are these three equations? A plus b plus c is equal to 3. 4a plus 2b plus c is equal to 7. And 9a plus 3b plus c is equal to 13. A few minutes back I said the number of unknowns is 3. So I need to have 3 equations. So now from there I can find the value of ABC, na, dear students?
Yes.
And that value of ABC you will get it, and you will find that even you apply there. I want you to find the value of ABC from these 3 equations. Please send it to me right now. Tell me, actually. You need to work on it to find the value of ABC, and do let me know what is the value of ABC you got.
They all won.
Very good. Appreciate. They all are 1. Very good. So that means what we get, the value of, dear students, if you say, thanks Agni, A is equal to 1, B is equal to 1, and C is equal to 1. Then apply these values of ABC in this one. What we are going to get? Un is equal to, you get n square plus n plus 1. See? So easily we find the nth term. And there is no trial and error method, dear students. It is very well defined. I'll come back to theory after a few minutes. But first understand the first order difference, second order difference. You will not find this is in NCERT book, or most of the book it is not there. You will find it in my study material. That is there, that I'll share with you. So now, how you can verify that you have done correct? Put n equal to 1. U1 is already given 3 now. And you put equal to 1 square plus 1 plus 1. 2. Put n equal to 2. N equal to 2 should be, U2 should be 7. So 2 square is 4 plus 2 plus 1. That is equal to 7. Na? Are you getting my point, Disha? Are you getting my point? So,
Yeah.
so the point is that
Yes.
whenever we get some series, I repeat with the statement I started the class. Whenever you get a series where you are not able to find any specific pattern, then approach the concept of first order difference, second order difference, third order difference. I'll come to that theory. So this we will discuss, for the next 10 minutes about the theory. So what is that? Let a sequence is given like the following. Okay, let me share the theory first and then we'll discuss. Okay. Just a minute. Able to view this thing, no, dear students, very clearly.
Yes.
Huh? Okay.
Yes.
Just a minute, if I can move it a little bit. Okay, fine. That's fine. Okay, let's go through it properly. So what it says that let a sequence is given to us like the following: U1, U2, U3, and so on. And by initial inspection, we are not able to find the nth term of the sequence. And by initial inspection, if we are not able to find the nth term of the sequence, we can follow the steps mentioned below to find the nth term. If the first order difference are constant, okay, if the first order difference are constant, then assume the nth term un as an plus b, where ab belongs to r. Got it, no, dear students?
Yeah.
So what is the first order difference? So let me write it down here, or I can write in the above also. The first order difference order difference will be, let me write in the below so that you can later follow it actually. Just a minute. Let me write it here. Let me write a different color. So if U1, U2, U3, U4, and so on is given, the first order difference would be what? U2 minus U1, correct? No? Then U3 minus U2, correct? Then U4 minus U3, and so on. Correct? So now we can name, so this is called the first order difference is constant. Then we will assume, so if we leads like a constant, like the way we got in the right hand side, the second order difference we got constant 2, 2, 2. Then, but in this case, if the first order difference are constant, you assume the nth term equal to an plus b, and after that you can find the value of a and b the way I said, because u1 you apply n equal to 1, you get an equation, correct?
Yes.
That a plus b equal to u1. u1 will be given to you, na? And
Yes.
how many equations you need here? You need only 2 equations because there are 2 unknowns a and b. No? And then u2 you can find out 2a plus b should be u2. Okay. Now, if suppose first order difference is not constant, which happened to our case, no? If you look into our case, our first order difference is not constant. First order difference is 4, 6, 8, 10, which is not constant. Then we'll go to the second order difference. If the second order difference is constant, then we assume that nth term un is equal to an square plus bn plus c. And that's what we have done it here. An square plus bn plus c, as the second order difference is constant. Correct, na?
Yes.
So how to find second order difference? So we can assume, we can give a name, the first order difference as delta, delta u1, delta u2, delta u3, like that. Correct, na? Are you getting my point? What I'm talking about? So what I'm saying is that the first order difference, what you see here, dear students, is that we can give this name as delta u1. This we can give as delta u1. This you can give name as delta u2. This you can give as name as delta u3, and so on. So how to find second order difference then, dear students? It is delta u2 minus delta u1. Correct or not? Huh?
Yes.
Second order difference. Second order difference, we get delta u2 minus delta u1, then delta u3 minus delta u2. Correct or not? Delta u2, then delta u4 minus delta u3, and so on. That is the second order difference. Now, if we find that second order difference is also not constant, then we proceed to the third order difference. And I hope you understand by now what is the third order difference.
Yes.
Is that, difference of the second term of the first order difference from the first term of the second order difference. Correct, na?
Yes.
Correct or not?
Yes.
So second order difference we can give is the delta square u1, delta square u2, delta square u3, like that. Correct, na?
Yeah.
We can give name like this. So if the third order difference are constant, it has to be third order difference as constant. Then we assume that un equal to a in power 3 plus bn square plus cn plus d, where a, b, c, d belongs to R.
Yeah.
And after that it will not come. That's fine. Up to third order difference. Okay.
Yes.
So we can give this delta u2 minus delta u1 by as delta square u1. Correct, na?
Yeah.
Delta u3 minus delta u2 as delta square u2. Delta u4 minus delta u3 as delta square u3. Correct, na, dear students? Then what we are going to find? We are going to find the third order difference. Third order difference. Third order difference, what we are going to get, dear students, is that delta square u2 minus delta square u1. Correct? So that is delta square u2 minus delta square u1, then delta square u3 minus delta square u2,
Yeah.
then delta square u4 minus delta square u3, and so on. We can name this, third order difference as delta cube u1. Correct, na?
Yes.
Delta cube u1, then delta cube u2, then delta cube u3, and so on. So if that is done with the first three one. Now, if none of these first three is working, means if we do not find the first order difference as constant, or second order difference as constant, or third order difference as constant, then what we should do as student is that we will come to the first order difference they are in GP or not. If the first order difference are in GP, got it? With common ratio R, then we will assume the nth term is equal to a into r to the power n plus b. If the second order difference, if the first order difference are not in GP, then we will find the second order difference. And if we find if the second order difference are in GP, then we will assume the nth term as a r power n plus bn plus c. Dear student, very carefully note it down that, you know, a into r power n, r is the common ratio,
Yeah.
plus bn plus c. Okay,
Yes.
got it?
Yes.
And what is un is a r power n plus b. Got it now? But that is for the when the first order difference in GP with common ratio r.
Yes.
Got it now?
Hmm. Yes.
So then we will assume un equal to a r power n plus bn plus c. Now if the second order difference also not in GP, then you will find the third order differences. If the third order difference are in GP with common ratio r, then what you will do? Then we will do that un equal to a r power n plus bn square plus cn plus d. You see, isn't it a very specific way of finding it without
Yes.
trial and error method?
Yes.
So what you see, there are 6 steps, one by one. I just repeat once, and after that I'll go to the next topic. So first is that, first you find the first order difference. First you need to know how to find first order difference, second order difference, third order difference. Till that, first you find first order difference. If the first order difference are constant, then assume the term as un nth term is equal to an plus b, where ab belongs to r, and you will know how to find the value of ab. If the second order difference are constant, then you assume the nth term as an square plus bn plus c. Means if the first step doesn't work, then you come to the second step.
Yes.
If the first 2 steps are not working, then you come to the third step. That is, if the third order difference are constant, then you assume un equal to an cube plus bn square plus cn plus d, where a, b, c, d are constant. A, b, c, d are real constant. If none of these 3 are working, then come to the fourth one. You find the first order difference are in GP or not. If they are in GP with common ratio R, you can find what is the common ratio if they are in GP. Correct, no? Then
Yes.
assume the nth term is equal to a r power n plus b. Okay? Where AB belongs to R. If the second order difference is in GP, if the first order ordinance is not in GP, but the second order difference is in GP with common ratio R, then assume the nth term is equal to a r power n plus bn plus c, where a, b, c are real constant. Now, if you find the second order difference are also not in there, then neither in GP nor constant, then you find the third order difference. The third order difference if they are in GP, then you find that nth term as a r power n plus b n square plus c n plus d. So if you follow these steps, it's fantastic. You can do any sum. Correct, no? Are you getting my point, dear students?
Yes.
Okay. Now, just to understand how well we understood, I just want to give a small question. Is it fine to give let us all of us solve it?
Yes.
Okay. And before that, do you want to write it down? This one?
I noted it.
Okay. If someone wants to take you can take a photo of this thing of the screen. You can take a screenshot and keep it, because the next problem what I'm going to give is going to help you. Or if you tell me to scroll down the page, that also fine. The question here is that find the nth term of the sequence. Sequence series in this context are is same in this context. Find the question here is that find the nth term of the sequence 10, 23, 60, 169, 494, and so on. Okay, got it, no, dear students?
Okay.
Please note down this and start solving it. Huh?
Yes.
All right, go ahead. I just want to give you, some 2 to 3 minutes. Within that, you can solve it. If you write down the question properly, please do let me know so that I can take you to the theory part. All of you wrote the question?
Yes.
Disha, Srijita,
Yes.
Divansu, Gurman. If you write the question, then you can.
Yes, sir.
Okay, great. In fact, with this, I put both the questions and theory in the same page. Okay, all right, go ahead. And do let me know what is the nth term. How's the progress, dear students? Able to make it? What kind of pattern you found out? What is the
So,
first order difference?
is it 24, 72?
24, 72, 216. Did you get anything?
GP of second order difference.
I'm sorry?
So GP of second order difference.
Okay, it is a second order difference. Hence, and that though these are in GP,
Yeah.
correct? So first order difference, quickly if we do, the first order difference are what? Is 13, right?
13.
First order difference are 13. Let me use a different color. First order differences are 13, comma, then you get 37, na?
Yeah. 109.
Then 109,
3
and
2.
then you get 335, correct?
Yeah.
And so on, correct?
Yeah.
Now the point is that if you the moment you see this thing, they are not in pattern, so you go for the second order difference. Second order difference, we get 24. Dear students, if anyone is not able to find it or not able to understand it, never hesitate. Then 24, 72, and 216, correct, no?
Yeah.
So now these are in GP. These are in GP with common ratio 3, 3,
Yeah.
correct, no? So what will be our nth term? That is UN. According to our understanding, UN should be what? Which one is it is actually falling? It is A into R to the power n plus Bn plus C, correct, no?
Yeah.
So that means UN should be equal to, let me use a different color. So UN should be equal to A will be there, A into 3 to the power n plus Bn plus C, correct or not?
Yeah.
Now you know how to find the value of ABC, because we'll apply U equal to, n equal to 1. If we apply n equal to 1, what we are going to get? We are going to get 3 into A, isn't it? We are going to get 3 into A. If we apply n equal to 1, we will get 3 into A plus B plus C, that is equal to 10. If we apply n equal to 2, what we are going to get? We are going to get 9 into A plus 2 into B plus C is equal to 23. Correct, not dear students?
Yes.
If you put n equal to 3, what you are going to get? If you put n equal to 3, what we are going to get is 27A plus 3 into B plus C is equal to 60. Correct, no?
Yes.
Now you can solve it. If you solve it, could you please tell me what are the values of ABC you are getting?
I'm still doing.
Okay, do it first. Sagnik, Devanshu, Disha, Srijita, anyone found out what is the value of ABC?
So is it 2, 1, and 3?
Yes, fantastic. Absolutely. The value of A is 2, B is equal to 1, and C is equal to 3. So A is 2, B is 1, and C is equal to 3. And as you get this thing, so it is quite simple to find the nth term. So what will be the, what will be the nth term then? The nth term, just apply all these values. So we are going to get the nth term, or I can write here. The nth term, what we are going to write now is that UN is equal to 2 into 3 to the power n plus n plus 3. Correct, no? Two into 3 to the power n plus n plus 3. That is the nth term. And not only this student, if there are questions, find the sum up to the first n term of the series. Not a big deal. That also you can do now.
Yeah.
Suppose the question is that, sum up to the first n terms, and if you define this as Sn, not a big deal. 2 into sum of the 3 to the power n, no? Plus sum of that n, and 3 into sum of 1 up to n times, where n is equal to 1 to n, correct, no?
Yeah.
N is equal to 1 to n. In case this question is there, n is equal to 1 to n. What is this? This is in geometric progression, the first one. Let me use a different color. This is in geometric progression with first term as 3 and common ratio is also 3. This is the sum up to the first n natural numbers. There is a specific formula, n into n plus 1 by 2.
Yeah.
And this is one is that you are adding 1 n times, that is nothing but n.
And
Good thing, na? I hope you appreciate that today what we have learned.
yes.
Now what I'm going to do is that I'm going to do the next one is that is called the infinite series. And this you will find pretty interesting. And I'm just going to go to the next page to discuss on that infinite series. So what happens, dear students, in the infinite series is that a series of the following form. I'm just going to show you what is that form. Dear students, you have some more minutes now, some 15-20 minutes. Can we continue, right? I hope it's fine. Okay. So what is that infinite series? If you see, a series, of the following form, that is u1 plus u2 plus u3 up to un and up to infinite, is known as infinite series, where un denote the nth term of the series. Correct, no, dear students? Okay. Now, I just want to touch base with the infinite geometric series. We already discussed this thing, but very, very important. Hence, we should repeat once, and you also take a note of it. If you recall, dear students, that infinite geometric series is something where it goes from a plus ar square up to ar to the power n and so on till infinite. It is a series. Series means summation of those terms, right? Sequence means the terms. Series means summation of those terms. So this is an infinite geometric series. Now, if r is a proper fraction means what? The absolute value of r is less than 1. That is called a proper fraction. No? If r is a proper fraction, let me use a different color. If r is a proper fraction, okay, that means if mod of r is less than 1, that is minus 1 less than r less than 1, then a plus ar square up to r to the power n up to infinite should be equal to a by 1 minus r. Correct, no? That we already discussed. But if r is not a proper fraction, that means if either r less than minus 1 or r is greater than 1, then the value of the infinite geometric series does not exist. Okay? Clear, no, dear students? We discussed about this point.
Yes.
Okay? If someone wants to know more, then you can look into my previous class note and video lecture as available. It is available on YouTube as well. Okay, now I'm going to discuss something about the exponential series. Okay, and that you will find pretty interesting. What is exponential series, dear students? Okay, we have not discussed about that. Binomial theorem. So I will suggest you that you for the time being please assume this thing. Okay, a series expansion. If you look into let me first put the note and then I will explain. If you look into this, dear students, as you see in the screen, we'll see later about the binomial expansion. If you see that 1 plus 1 by n power n, that expansion is 1 plus n into 1 by n plus n into n minus 1 by factorial 2 into 1 by n square plus n into n minus 1 into n minus 2 by factorial 3 into 1 by n cube and so on. Okay. That you assume for the time being, dear students, okay? Because when you discuss binomial theorem, you'll see it, all these things in details. But you have a good concept about the factorial, correct?
Yes.
And we have rearranged that term. So first term is 1, second term n into 1 by n, that is also 1, correct? No? Then third term is actually n square we are dividing. So 1 by factorial 2, 1 minus 1 by n, correct? No? Because we are dividing by n square. Similarly, 1 by factorial 3, we are dividing nq is there in the denominator, so we are dividing n with each one. That is n by n is 1, n minus 1 by n is equal to 1 minus 1 by n, and similarly n minus 2 by n is equal to 1 minus 2 by n, and so on. Now what we are going to do, dear students, is that we are making a limit. After coming to the second step, we are making a limit of n tending to infinite. You have a very initial and fair amount little idea about limit, that if you take n tending to infinite, then 1 by n, 1 by n, 2 by n, all these things will be tending to 0, na, dear students? Because n is very huge. If your denominator is very huge, then the value of that entire fraction should be nearing to 0, correct or not?
Yes.
Okay, so what we are going to get it is that, so 1 plus 1 by 1 factorial plus 1 by 2 factorial plus 1 by 3 factorial, we get this thing, correct? No, once we finding that value of this thing. Okay, so what is the exact purpose of my discussion about that, this particular series called exponential series, is that this equation 1, what you are seeing now, dear students, we see that the limiting value of 1 plus 1 by n power n as n tending to infinite, okay, is an infinite series, correct or not?
Yeah.
Clear or not clear? So what we see is that, that as n is tending to infinite, what we are going to get? We get that the value of 1 plus 1 by n, correct, no? The value of, as you see, dear students, that the moment we find the, limiting value of 1 by 1 plus n power n is tending to, a specific value called 1 plus 1 by 1 factorial plus 1 by 2 factorial plus 1 by 3 factorial and so on up to infinite. And this series, what you see in the right hand side, dear student, is that 1 plus 1 by 1 factorial plus 1 by 2 factorial plus 1 by 3 factorial up to infinite is denoted by E. E, a letter. Okay. So we can write that E is equal to what? Let me first put the note and then I'll discuss. So what we see is that from the above identity 1, we see that the limiting value of 1 plus 1 by n power n as n tending to infinite is the infinite series as expressed in the right hand side, correct or not? And this series is denoted by E, and it's called, E. Remember, we have discussed several times about E earlier.
Yeah.
The value of E is in between 2 and 3, and its approximate value we take as 2.718281828. But actual value of our E is an irrational number, but E is used a lot in mathematics, so we have approximated the value of E from irrational number to rational number, and its approximate value, as you see, is equal to 2.718281828. Like pi is also an irrational number actually, but for our convenience, we made it to a rational number called 22 by 7. Similar thing for E. Correct, dear students? Absolutely clear?
Yes.
Okay. Now, what we are going to find that e power x, Okay, that you need to remember is that, so what we defined so far is E. Now, for x belongs to R, the exponential series for x belongs to R. Let me show you the exponential series first, dear students. E power x equal to 1 plus x square by factorial 2 plus x cube by factorial 3 up to infinite. Very important to know. Lot of places it will be used in future. And similarly, e power minus x is nothing but just replace x by minus x in the above expression. Then you'll find that x becomes minus x cube become minus x cube, right? Like that. But x square, x power 4, that will remain same. And after that, we have added these two. Then we get this expression, and we have subtracted, we get this expression, correct? And e power x also we can define like this. This, all you need to just remember and explore. And also, once you are done with binomial theorem, you can also, evaluate all these things if you wish. Now, next one, what I'm going to discuss, dear students, is called the Euler's formula. Okay, Euler's formula will be, discussing in details when we'll be discussing the complex number. Okay, but today I just want you to, just remember this thing. And once we come to complex number, then we will again go back and discuss in details. So I can tell you in brief about the, about the Euler's formula. We'll see that e power x is equal to cos x plus I sin x. We will see it later. Okay, I is nothing but the imaginary number. And if you see, cos x plus I sin x is nothing but a complex number with real part as cos x and imaginary part as sin x. For any x belongs to R, the set of real number, okay, e power ix is equal to cos ix plus I sin ix. Now, we just learned about the formula of e power x, that is 1 plus x squared by factorial 2 plus x cubed by factorial 3 and so on. Instead of x, we are writing ix. So then what we can write? We can get this thing, that is equal to cos x plus I sin x. Now, when we will discuss complex number, we will see, dear students, if there are two complex numbers, that one is a plus ib and another one is that c plus id, then a real part is equal to the real part. A must be equal to c, and imaginary part is equal to the imaginary part, that is b must be equal to d. So that's what we have done. Cos x is the real part, so that actually we equated to the real part, that is this one. And sin x is the imaginary part, that we have equated, we get this one. This is the two very important series for sin x and cos x. Dear students, that entire algebra part is complete when we will discuss about complex number, linear inequalities, binomial theorem, and few topics we already discussed. And like sequence and series, and we discussed about permutation combination. Then we can leverage all these concepts in complementary manner. Okay, either to achieve any formula or to solve any particular question. Now, the last point, what I'm going to say, dear students, last but one point is the logarithmic series. Okay, that also I'll tell you to remember for the time being. And when time will come that we will discuss in details about logarithm, then again we'll come back to this thing. So what is the logarithmic series, dear students? Let me first show you the note. I hope you are able to view it in the digital screen. Log of 1 plus x base e is equal to x minus x squared by 2 plus x cubed by 3 minus, in that way it will continue till infinite when x is in between -1 to +1. So that is the first one, dear students. Second one is that log of 1 minus x base e, that is equal to -x minus x squared by 2 minus x cubed by 3 minus ... up to infinite when -1 less than equal to x less than 1. Correct? We will discuss all these things in details. But today, what you need to do, today you need to remember. And then once you discuss all these things, then you will see that, yes, how well actually this can also be established. Then log of x, 1 plus x by 1 minus x base e is equal to 2 into x plus x cubed by 3 plus x squared x power 5 by 5 plus dot 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 up to infinite. That you can find out just by subtracting this one from this one, because log of m minus log of n is equal to log of m by n. Correct. No? And if you apply, the value of x equal to 1, then you can find the value of log 2 base e. If you apply x equal to 1, you will get this series, na, dear students. So this is about, that infinite series, what I wanted to discuss with you. As time goes by, by looking into the newer questions in JEE Main and JEE Advanced in other engineering entrance examinations, we find some pattern, and from there, we get, some kind of, we also come up with some kind of pattern, some kind of formula, and then we will actually put it into the to your notice. So one such, I'm just going to these I defined as miscellaneous points, and those miscellaneous points becomes a part of theory later. So one such miscellaneous point, I just want to say you, and you can just remember and apply as and when required. What is that? It says that if the sum of the first in terms of arithmetic progression is a quadratic expression like in n, that is an square plus bn plus c, where ABC belongs to R and A is not equal to 0, then the progression is in AP with common difference to A. Okay? I repeat, if the sum of the first in terms of a progression is a quadratic expression in n, like an square plus 2bn plus c, it is given. Suppose someone is telling hey, I have a arithmetic progression, and sum up to the first in terms of that series of this arithmetic progression is something like that 5n square plus 3n plus 7. Then you can say, oh, that is in this arithmetic progression have a common difference of 2 into 5, that is 10, without doing anything. Got it? Second one is that let Sn be the sum of the first in terms of the progression such that Sn equal to an square plus bn plus c, where ABC belongs to R and A is not equal to 0, then the progression is in AP and the common difference is 2A. Got it, no? So that Sn actually I give a symbolic representation. So that's all about today's class, dear students. So tomorrow, what we will do, tomorrow we'll start a topic in physics, okay?
Yes.
And I'll explain you. We'll start with a particular, formula, and then we'll see. We'll take a problem, and you'll see that how the concept of physics is, why the formula is so important. The mathematical expressions are so important to solve a specific, problem in physics. So that we'll be discussing tomorrow. If you have any specific question for me, please feel free to ask. Otherwise, we can conclude the class for today. You will get the class notes in another 15 minutes from now, and the recorded version of this today's note in the entire recorded class note in another 2 hours from now.
Yes.
Okay, thank you very much. All right.